Hey, hi everybody. Can you hear me well on the chat? If yes, you can write anything on the chat and we can wait a bit and we can start. Okay, that's great, Santosh. Yeah, I see some familiar names there. So I will. Yeah, hi Ian, how are you, man? Great to see you. So let's wait a few minutes. Hi Milan, and we will start in at point 5. I will show you the agenda and a bit about me, even though some of you may already know me from LinkedIn, but we'll say for those who don't know. Let's give it one more minute and we can start. There will be a recording later on, so in case that someone has to drop later on the meeting, don't worry that there will be a recording of this, and I will send. It will be sent to you. Well, not sent to you, but it will be published on LinkedIn and YouTube. So you will notice if you follow me or Proficial Labs, you will get that for sure. Okay. So it's point 5 now. I will start. I hope you can see the screen. So today session is Kubernetes Optimization Masterclass to achieve financial agility with FinOps, presented by me, of course. So I will show you the agenda and then I will present myself a bit. So today we're going to see some basics on Kubernetes resource management, then some Kubernetes optimization tools. We will dive deep into several optimizations tools that are available for as an open source alternative, and that I think they are interested or they have helped me in my Kubernetes journey. And then we will continue to FinOps applied for Kubernetes. And finally, if we have time, I may be able to do a Kubegreen. I'm not sure about the duration, but if not, I will do it separately in a separate video. And then the next steps for you with some relevant information, and I will be sure to do it, and then some Q&A session. So beforehand, you can put your questions in the chat. I will probably not be able to respond up until the end, but you can be posting them and then I can address it at the end of the session on Q&A. And there is also, I believe, a Q&A part that functionality on Zoom that you can post them there, but I will be able to see them on the chat. So I will start now with a brief introduction. Victor Garcia, as you may know me, so I'm a cloud DevOps engineer with more than 6 years of experience working on cloud projects. I recently worked in a complete migration from monolith to microservices using Kubernetes, so I learned a lot related to these tools, and apart from all the intricacies that it has, and I'm now using it day to day. So I am used to deal with Kubernetes, and I'm trying now to apply my FinOps knowledge to them. So I happen to land in some optimization tools that I think they are valuable and I will share with you today. And as some of you know, I am focused now on FinOps. I share a lot of content on FinOps. every day on LinkedIn and with my newsletter, FinOps Weekly. Every Sunday, you get the news that are from the sector, along with some relevant articles and some mentions. So if you haven't checked out, you can check it at finopsweekly.com. And also, I would like to thanks to Proficel Labs to giving me the opportunity to share some of my knowledge here today. It's been a pleasure collaborating with them and looking forward to doing this session. Okay, so without further ado, I think we can start. I will check it on the chat one sec to see if everything is going fine. I would assume yes. Okay. Thanks everyone for joining, and we're going to start. So the goal of today is talk about Kubernetes, right? So why focus on Kubernetes? So Kubernetes has been one of the most widely used technologies in cloud, especially since the apparition of microservices deployments or architectures from large corporations such as Netflix or, of course, Google, which originally make them. Kubernetes has been really, really important to the cloud ecosystem. But Kubernetes has a significant learning curve and it's complex. Everyone that has dealt with Kubernetes, especially at the beginning of your Kubernetes journey, you see the docs and then you are overwhelmed by all the duration of the library, all the things that you can do, all the elements that are new, services, deployments, pods, ingresses, config maps. I could be the whole hour citing these elements. So it's really difficult, right? And I think you need to know a lot, or you need to know several things to be able to use them correctly. And as I say, like, there are a great amount of resources and possibilities, and that makes it really flexible, really extendable. As the ones that you have used you can see that you can create almost whatever. As you may see, there are several tools that are based on the Kubernetes architecture that are crazy to be handled that way. And it's extendable and you can create a lot of things, but that means it's complex because you have to know several things. So one of the main problems is that it's a DevOps oriented thing. And as you may know, sometimes this orientation doesn't take the cost much into account. So now with the FinOps approach, we are trying to implement finance and cost into the DevOps cycle. So I would say that now this is going to change, as some orgs have noticed that the Kubernetes costs have been really up to the roof. So now we need to focus on Kubernetes because it's easy that your Kubernetes workloads get a lot of cost. So we need to take that down, and there are several tools that we can use. There are several optimizations that we can run. They are not that complicated for a Kubernetes level. So we need to be aware of them, and that's what I'm going to explain today. So yeah, I want to start by focusing on the importance of Kubernetes optimization, right? So as I mentioned before, there is rising cloud cost everywhere. Everyone is more concerned about cloud cost because there are even more workloads on cloud, and several are on Kubernetes environments, and everything, the bills are rising. And of course, Kubernetes is very prone to inefficient resource utilization, right? So you tend to put your limits, put your requests, and then forget about them, and you don't care anymore. But with that, what you are making, and we will see it later on the presentation, is that your resources are getting either more resources that they need or less resources, and they need to span more nodes so that they can live. And that's a problem, right? So this resource allocation for Kubernetes is crucial, and I don't think many companies or people do it because it's really complex to make it right on the first try or without several supervision, right? But there are good things on Kubernetes optimization, right? Because when you optimize your workloads, you can make more scalable products because they need less resources to do the same thing. You get less cost for the same value, which is the most important thing you need to do in FinOps and in cloud optimization, is to get the most out of each dollar that you spend on the cloud. And then you can get improved performance because you get your workloads to be using the exact amount of resources that they need. And if they need to expand, they will be able to expand. And if they need to compress, they will be able to compress. So you are able to improve your performance automatically and scaling properly. And also, if you do your resource and allocation properly, you would be able to determine what exactly are your workloads spending. So in this case, if you have services, you would be able to have your cost allocation so you can determine whether or not a product or a service is viable based on your Kubernetes spend. And also, if you do a correct optimization, you will be able to reduce the spend. And then probably it would make you a better product because your margins will be higher. And also because it's a new thing that engineers will be able to know. So if now the trend, especially on FinOps, is to parties to shift the cost part to the engineers because they are the ones that are handling the workload, so they can actually generate costs for the companies, not provisioned beforehand as it happened below, that you have your on-premise, everything was provided for you. Now you can create costs by the hour, right? So if you are able to create cost optimize Kubernetes workloads, you would be a more valuable engineer because you would have another factor taken into account and you would be able to create better and more cost efficient Kubernetes workloads. So it's an added value to all the complexity that Kubernetes has. So without further ado, we can start. So yeah, this is some meme that I found the other day while making the presentation. I feel really well represented. Sometimes you don't know what Kubernetes has prepared for you when you try, especially new things with new extensions or new applications. It's really difficult sometimes to make it work with all the extensibility such as customize, and then you learn about traffic, then the tools that I will share with you today. But it is what it is, right? We have a lot of workloads on Kubernetes and we have to learn how to deal with them. So let's get started. First of all, let's start with the resource management, a little bit of the explanation about the concepts. So yeah, I'm going to start with a bit of the fundamentals because this is critical to make your workloads perform properly. First is like the resource types, right? So these are all the factors that the Kubernetes workload will have to take into account, such as the CPU, the memory, etc. Right? You may be familiar with these parameters that you define in your Kubernetes manifest. So yeah, the CPU resources are of course representing the processing power, like how much processing power you associate with your Kubernetes tasks or your Kubernetes deployments. You would see that defined on your manifest, and memory is all the available capacity that your workloads will have to perform the data. So it takes more importance in one workload, such as, for example, Java with the heap out of memory issues, and some others you are more on the CPU because they are CPU intensive. And here is one of the most crucial part to be able to do a properly optimization, right? Which is resource requests and resource limits, right? So when you are setting your manifest, you set in your file the request and the limit. And here, one of the most important thing for the optimization is the resource request, right? So making a very good resource request an initial allocation will make your workloads be more efficient. This is because your Kubernetes control plane will be using these references to allocate resources in terms of what the amount of the part of the nodes that will be associated with these pods, right? So in this case, if you, for example, set a workload that is a POC that is not getting almost any traffic to one CPU, and you have like 2 CPUs with the control plane plus some sidecars and this CPU, you will have your node full, and you will be using a full node for a workload that doesn't have any traffic. And you will be wasting one node that is costing you money in the cloud for almost nothing, right? So you have to be really careful about resource request. And it's especially crucial because this conditions your node types as well. So I will probably share, I don't have it on the end of the session, but there is a very useful resource, which is the Kubernetes instance calculator that sets on the resource request that your Kubernetes workload has and the specific instance type. I think it's in AWS, GCP, and Azure that you should be using. Depends on how much it's going to grow and the limits, etc. So this is, I cannot stop to make it a strong point. This is for making it, and you should be able to. You should be doing your monitoring for making the resource allocation correctly. And there are tools that can do that, but and we will see it later on. There are other tools provided by the cloud providers, but this is crucial for you. So you need to set this right. And this is going to condition, as I mentioned, all your workload for doing that. The problem with this, the normal thing is that you overestimate. So you would set resources that are not needed for this, and then you over provision, you cost more, your workload will cost more than default. But then there is the other part. You can underestimate your resources and they will crash, right? So if you, for example, set a Java workload that I am more familiar with to, I don't know, 500 megabytes of memory, and then your application starts working and it gets, I don't know, a Spring Boot application that makes almost a gigabyte if you test it on your Docker local environment, it will crash and it will reboot again. And it will happen again over and over again. And you will have issues because of this wrong estimation. Your pods will be rebooting over and over again with a lot of frequency. And then your workload won't behave as expected. So you need to be also aware that you don't under provision, but probably you should be more focused on not over provisioning, because that's what you're probably doing if you are like me. For example, that's what I tend to do, right? And then this is very related to the cluster autoscaling, as I mentioned, right? So based on the resources, the cluster will be doing its autoscaling based on what you request and based on the CPU consumption and all these considerations. It will be doing its scaling. So I'm going to try and explain to you how does it work. So first, the cluster autoscaler is constantly checking if there are any pods that can be scheduled due to inefficient resources, crash loop, backlogs, whatever. But in this case, we're going to focus on inefficient resources. So now when it finds these pods, it calculates how many nodes are needed to accommodate them. And then it communicates it with your cloud provider to request that additional node. So you need to have this enabled. I'm familiar, for example, with GKE, and you have to enable this, as well as if your node pools are limited based on your constraints, you need to set them so that they can span nodes, because you can limit the amount of memory and CPUs that you have enabled. So that could limit the number of nodes as well as the total number of nodes. So you need to be careful around that, because if that happens, you will still have failing nodes. You can deploy new pods, and basically your workloads stay like this because you have limited it. So now, if this is enabled and works right, so once the new nodes are up and running, Kubernetes will schedule the pending pods into this node, and everything will work. So that happens again if the same way, but to scale down, right? So the cluster autoscaler is also smart enough to scale down when resources are underutilized. So it identifies the nodes that have been running below a certain threshold for a specific time. And then if they can move the workloads to another node without crashing anything, it will do so that the resource consumption is less. So that's why I am saying to you that cluster autoscaling and well configuring it is crucial, because you can have benefits such as the cost efficiency. You will only pay for what you need if you set it up right. You improve your resource utilization based on your allocations and based on your types. That's why I say before that the node instance type is crucial for your workload. So for example, if you have a memory intensive workload, use a memory with a high memory type of instance. If you have CPU intensive workloads, for example, any C or any Python in this case workloads, focus on CPU intensive if you need them. And then be aware that the size of your node is also crucial, because, for example, if you have sidecars such as, I don't know, Prometheus, Grafana, etc., you would need to provision enough resources per node so that those sidecars are enabled on each node. Okay, so this is something that I have dealt with in the past, and it was a very problematic thing because I like small instances, and then we had a large a large workload on a cluster, and all these sidecars were like almost filling up the node instance that I used. So take that into account and pick the correct node instance, because also the provider like GCP, Azure, AWS will put a constraint in, will put workloads for making the cluster work as well in your node. So be careful around that. And then it's important to consider also these things, like what I said, the min-max nodes, just in case, I don't know, you get a DDoS attack, and then you prefer to limit that so that you don't get your spend up to the roof. Make your applications that are designed to be stateless. So if a node is deleted, or if there is a crash, your workload needs to be able to redirect to other new nodes and don't care that much about the state. Or if it needs the state, it needs to be somewhere else, because otherwise your application will crash, such as, for example, having a database, you need to be able to replicate that. And then, of course, monitor your workloads to know whether or not you are allocating resources correct and if you are being efficient in your nodes. Okay. And then we are going to dive into a concept that is related to this, that is the pod priority and preemption. This could sound a bit complex, but I will try to explain it to you as easy as I can. I'm going to take some water to do this. So in this case, the pod priority is basically having different classes, tiers, levels of for pods, right? So setting a pod priority, like for example, would say on your DNS level, you can set priority levels, any priority system. You could say, okay, this pod or this workload is more important than the others. When you are saying this to Kubernetes, you would say, schedule this first and make it so that it's less evicted than the others. Make this a priority. So for example, when you have a critical workload that needs to be always working 100%, and if everything crashes, you need that does this workload crashes the last one, definitely you need to have this prioritized. That's what you work with pod priority. And then you have preemption, right? So when you preemption works like moving or upgrading up a pod to a first class when everything is full, right? So Kubernetes will actually evict lower priority pods to make room for the high priority one. So like you are saying to the other pods, like give place to this pod because there is the priority and we need this pod to make our application work. Like this could be problematic, or when should, right? So as I mentioned, critical services, things that you have to be running, yes, at all cost, you need to set them up for those. And for example, if you run batch jobs in your workloads, definitely, because if those jobs have are stateless, less time sensitive, and they tend to get like a lot of resources, you can set them lower priority so that in a case of an extraordinary event, those resources are not used, and then your critical services will be there working at all costs. But if everything is the same, Kubernetes will decide based on other considerations, and you won't be able to get your critical services up and running. And then, of course, cost optimization, right? So you can ensure this way that your most critical workloads get resources first. And then if something happens and you limit your nodes because whatever constraint on the cost term, you will know that the resources that you want will get the specific the services that you want will get the specific services, the specific resources in case there is a limitation. And then other things like secondary jobs won't be able to run if you are in a constraint. And I think that for large situations it could happen. So prior to this, instead of having preemption, eviction of nodes, what we could do is right size. So this may be a word that you have seen a lot, especially if you follow the FinOps community in general. So basically what you try to do is allocate the specific resources to the specific workload. Just enough memory, just enough CPU, just enough storage to work efficiently and don't waste, because several percent of the cloud is wasted resources. So how you can do that? You can monitor your usage over time to see whether or not you are consuming a lot of CPU, a lot of memory. You would probably see if you now later on the session, you can click on your resources. You would see probably that your CPU is lower than you expect and there is not that peaks that you assume. So definitely check that on your provider because you would probably have a surprise. Check your logs to see if you have the resource conditions are fine, if you have an eviction lately because you haven't happened to under provision. Check how many restarts your service has. Maybe you have a problem with the allocation in memory. So be careful around that. So I'm going to share some tools that can help you with right sizing. This is some of my favorite ones. So first one is the Kubernetes Vertical Pod Autoscaler, VPA. You may be familiar with the horizontal pod autoscaler that lets you scale the number of nodes based on the workload. And this is a great tool and it's more common because we always want to scale, right? But vertical pod autoscaler is, as you may know, vertical scaling is reducing the amount of resources for a specific instance, node, pod, etc. So this tool will automatically adjust the CPU and memory reservations depending on how you set it up to what the workload is doing. You can set it up in different modes. I will explain it later. That just recommend, and this is by default my recommendation, but the VPA is a very good tool for initiating yourself on right sizing. Then it's Prometheus and Grafana. If you're on DevOps, you probably know them. you would be monitoring your CPU and memory consumption, any other metrics that you want, and you will understand your resource patterns and see whether or not you need to adjust your services. And also we have Kubegreen that allows you to right size to 0, because it will sleep your workload to when you have non-production times on non-production environments such as test. We let our workloads run there indefinitely, and we can just shut them down when we are not working on them, and we will save a lot of money. Because if you think you are sleeping, imagine that you are sleeping 8 hours a day. So imagine that your workload is idle for 8 or 12 hours a day if you don't happen time zone difference on dev, then you would be saving half of the budget approximately just to sleep in your workload, because your cost will be gone to 0. You may have to pay the provider to admin the cluster, but if you can reduce your nodes to 0 or a small one, then you would be saving a lot of money for your company. So definitely take this into account, because this is one of the easiest ways to save money, is to prevent your dev environments to run every time if you don't need to. So as I said before, and I want to make this very strong point in the presentation, the Kubernetes resource allocation is the main reason your cluster is wasting money. Focus on that, review that when we end the session, and see if you're allocating resources right, because this is probably where your leaky bucket is in terms of cloud cost. And now I'm going to talk about Kubernetes optimization tools. So as I mentioned before, there are several tools that you can use. I will talk about Kubegreen. It's a very useful tool, and I will probably don't have time to show you a demo, but I will put all the links in the presentation. Kubegreen is a very good tool to sleep your workloads. Then we have the VPA to adjust vertically your pods and the resources that you have. Then we have the HPA, or horizontal pod autoscaler, that it will be able to reduce or expand the number of nodes that you have based on the condition that you set them up. And then we have the MultiDimensional Scaler, which is combining a VPA and an HPA together, that we will detail in the following slides. Because you have to be careful combining VPA and HPAs. There could be conflicts, as you may think. If you try to expand vertically and horizontally on the same level, on the same metrics, you will have conflicts, because what's the priority, right? So with this approach, you can solve that problem, and you can have a more efficient workload system. So I'm going to explain what's the purpose of each tool, right? So Kubegreen. The use of Kubegreen is extremely simple. As I said before, the goal is to sleep pods or deployments that you have running when you consider. So if you are familiar with cron jobs, you will be seeing this system, and there is a couple of, let me, one sec. A couple of questions in the chat. I hope I'm able to see them. Okay, yeah, Prandeep, have a nice one. As I was saying, Kubegreen is a cron job, basically. There is more complexity under the hood, but if you think of it as a cron job, it will be really great. So you have to install it easily with a CRD that you can do kubectl apply, and then the URL to the file, to the YAML file is really easy. You only need cert manager to have it running. And in this example, here is working hours, right? So let's think in a very optimistic way that the last hour that you end up is 8 p.m. And then when you start working on your workload is 8 a.m., right? So in this case, what this manifest will do is sleep your workload, so set them to 0. then wake them up on the 8 a.m., suspend all the cron jobs, and then you can exclude workloads, right? So you can exclude them by setting the deployment. In this case, if you don't want a specific deployment to be sleep, because I don't know, maybe it's a monitoring thing that you need to run constantly, or an API gateway that you can shut down because then the domain won't work, things like that, you can exclude them. So it's extremely easy to make your resources to 0. You can set them up based on the namespace, and it will work right away. So this is some of, I think for being a Kubernetes tool, is one of the easiest. It's easy to comprehend because if you are familiar with cron, the settings are very similar. You can do also conditionals based on that. So every 5 minutes, create don't sleep or wake up, and then every, I don't know, 10, you could sleep then, just in case you need that, or any cron configuration that you may do. So this is some of my personal recommendations. I happen to talk with the guys that work on this, and they are great. And it also saves you, waste resources. There is a part of carbon footprint that is very well concerned. So definitely a recommendation. And you definitely should take a look into that for your dev and test environments. Then we have the VPA. So sometimes, as I was saying, we overestimate or underestimate what we need in our workloads. And that's why we need a VPA. So it will monitor your resource usage of your container, and then it will be able to adjust or recommend the memory and CPU request limits to optimize your resource allocation, right? So here's how it works. The VPA will observe the actual resource usage of your pods over time for the workloads that you are setting it up. It will analyze all the data and determine the optimal resource requirements. And then, based on this analysis, the VPA could automatically update the pod's resource request and limits if you set them out to auto, or provide recommendations for manual adjustment. This is my preferred option when you're starting, especially if you have HPAs that I will address later, because it won't affect your workloads. You will have the information, and then you can adjust. And after that, when you are sure you are correctly allocating resources, you would be able to put it on automation and make your resources adaptable. So when you should use this? When you have a workload that you are not sure whether or not it's consuming, and you have a certain metric that is very variable, put a VPA, maybe remove an HPA if you have a considerable node instance size, so that it's able to process all the workload. If you want to maximize your resource utilization, you definitely need this or any other similar tool, but I would recommend starting with this, because you will be able to know based on an automated tool, what's the required allocation that you need for your workload. And then it will let you not make a guess on this work. But you need to be careful about this, okay? Because VPA has some constraints. So to adjust resources, the VPA could restart your pods. That could be problematic. So if you have critical workloads that are not able to be restarted, or they are not provisioned to more than one replica, then you should adjust that before implementing VPA, especially on auto mode. Otherwise, you will have failures, and nobody wants that. Then, as I was mentioning, it's not compatible with HPAs on the same resource metrics. So you will need to choose between vertical and horizontal scaling for each metric. You can combine them, and we will see it later, but they need to be on different metrics. So for example, putting an HPA on memory and a VPA on CPU. You need to adjust that, because otherwise there will be a problem. And as I was saying, test it out, use it on recommendation mode, just to see if you're allocating right, and then set it up to automation because it could impact your application, and we don't want that. So we want a working application that is consuming the resources that it needs, but we don't want to crash our applications because we are trying to save some money. So be careful around that, use it, and let me know how it goes. And then we have the HPA. I'm going to be brief on this one because most of you may know it. It will monitor your workloads and see the target values that you have set. So for example, if a workload has more than 80% CPU consumption, span a new node. And then of course, the scale down, you can set them up as well. So this is very useful for a microservices architecture or anything that can scale vertically without any other communications. Batch processing when you need to have workloads running in parallel and can have to provide large amount of data, you can leverage it. In case that you need to make them faster, you can set them to scale to whatever you want. And then of course, web applications, I use them because for traffic fluctuations that you cannot handle in a single node, in a single pod, as using the VPA, you will have a problem there, and then you can expand with your HPA to expand the workload. So when implementing the HPA, choose the appropriate metrics. CPU is common, but you can use custom metrics. I don't know, for an email service, you can set the amount of messages that you get from a PubSub app, you are getting from a PubSub app, requests, etc., etc. Use realistic targets, so analyze your workloads and see whether or not you are overestimating your scalability and you're scaling too late or too soon, and then test it. Make load tests to see if it works as expected and if it's actually scaling, because sometimes you might have misconfigured it and you won't be able to make it work right. And then here's the combination of both. The multi-dimensional pod autoscaler. So this was by Google on their GitHub, and I saw it also on the GCP Cloud blog, sorry. So basically, the multi-dimensional pod autoscaler is a single object that is managing both horizontal and vertical autoscaling, but separate them on different metrics. So it can evaluate multiple metrics at once, and then based on that, it can scale horizontally or vertically your workloads. So this is probably a complex tool for most of you, but I would definitely suggest to review the link with the documentation and see if you can take a look at it. Because for specific workloads that are very dynamic and can increase on multiple directions, or you have to take into account multiple metrics, it can be really useful, and it can help you a lot to reallocate resources and to be able to scale your solution properly. So as I was saying, combining the VPA and the HPA, is probably one of the easiest in terms of what you need to do to scale your workloads. And this is an approach that is very valuable for doing that. So it's, as I was saying, it's not another autoscaler, it's the combination of both. It's doing what I was mentioning about combining VPA and HPA, different metrics, so that they don't crash. Because otherwise, definitely it will be a problem if the VPA is set on auto mode. And then it will be a more flexible workload and with reduced operational overhead. So if you understand the solution and if you take a look at it, you can leverage it for complex workloads that have an unpredictable resource consumption. And with this, we end up the Kubernetes optimization tools. Yeah, we'll have time to do some Q&A, definitely I won't be able to show the demo. So let's start with the FinOps for Kubernetes, right? So FinOps basically is a cultural practice to bring financial accountability to the variable model of cloud computing in terms of cost. So we need to apply these principles to our Kubernetes workloads and our team culture so that we make our Kubernetes efficient in terms of cost awareness. What we need is implementing practices such as regular cost reviews, meetings to see whether or not we are growing too much. We need to be aware of our cost in our Kubernetes. We need to implement things such as chairback or showback models. That means knowing what each of the workloads are costing to each of the teams, or chargeback, charging directly to those teams based on the type of consumption that they have. And you need to provide the cost visibility to all teams. This is some practice that it's happening that some engineers don't have access to the visibility in terms of the cost. If you want your engineers to be able to fix the cost, they need visibility to that. Otherwise, they will be blind in that term. So by implementing these FinOps principles and strategies, we can make a cost-efficient Kubernetes environment without sacrificing scalability, performance, reliability. So it's just to be aware, be conscious about this, and make them efficient so that we can keep doing Kubernetes every day. So some of our practices that I will suggest is applying some kind of tagging or labeling strategies. You can do it in your provider or setting it on your Kubernetes manifest so that you know what services is consuming what resources. This is critical. This is cost allocation. This is fundamental to know what you're doing in the cloud. Then use spot instances. So Kubernetes will be set to most of the time to stateless workloads, and they can tolerate the outage of a node. So the spot instances are extremely cheap compared to on-demand instances, and they can be reclaimed at short notice. But if you have set up your workload to be stateless and be tolerate to interruptions, such as bad jobs or environments, spot instances will save you a lot of money. And lastly, we have the regular auditing. So using monitoring tools, using automations, using regular team meetings, you can see your usage, you can be aware of it, you can identify idle or oversized instances, and you can adjust your configurations. So it's not a one-time task, it's a regular thing, so you don't forget about doing it. So if you implement this, you would probably be able to know your cost and reduce them. So this is critical. Apply these FinOps practices into your Kubernetes workload. And then some summary and next step for you. I want to see the key takeaways that we have done today. Leverage optimization techniques, the right sizing, the scheduled scaling, for example, tools as Kubegreen or the HPA or VPAs to help you there. Use them. Scheduled scaling can be extremely useful. Use your node types accordingly to your workloads because you need them to be cost efficient. Use tools that you have, either if you want to use paid ones or you can use open source ones, the one that I said to you. Use things that have been already done for this and try to analyze your system so that you can optimize your Kubernetes environment. And last, implement FinOps. This isn't just a buzzword or a trend. It's a shift and it's here to stay. Embrace the principles, learn about the framework, and align all your personas that you have in your team to be aware of the Kubernetes costs because this will make your application better. This will make your services more, because they will be using less resources to make the same amount of workload. So once you make that, you can scale them more because you will use less budget for doing the same workload. I cannot stress this enough, because the whole idea is to get the most out of every dollar, and this is the most important thing you can get out even today if you don't want to use the tools. So with that, your workload will be probably equipped to drive Kubernetes to a whole new level. So this is how you can learn. Start with the memes. No, just kidding. Work on production level if you can. Use the docs. They are really great. They are dense, but work on them. There are several organizations that are working on really good Kubernetes tutorials. And, learn about Kubernetes and cost optimization for Kubernetes, because this is going to be a problem that we will need to be solving in the next few years. So where you can learn more, right? You can use my newsletter. I like Kubernetes, as you have seen, and I like FinOps. So I will try to bring all this content to my newsletter, FinOps Weekly. Hands-on labs or hands-on experience, if you can, please do. This is where you learn, where you actually learn if you do things. Use the docs as a reference. They are amazing, probably one of the most amazing things that you can see on the open source environment. And leverage companies engineering blogs. So this is some of my secret sources, is companies that are great, such as Adidas, Zalando, Meta. They share detailed blogs with a lot of implementation detail. Spotify as well. They have their engineering teams sharing tons of information that are very detailed technical content that is really difficult to get, and that you can get from ChatGPT or whatever. I would definitely recommend reading these blogs, because there are really good professionals making them, and I learned a lot from them, and I definitely encourage you to do. So some resources, I will try to share this. I don't know if probably in LinkedIn as a carousel, or I will try to share, because these are all the links that I have been using for today's presentation about prop preemption, right sizing, the cloud autoscaling, VPA, HPA, Kubegreen, and the MultiDimensional Scaler, and of course the link to the FinOps Weekly, Adidas blog, Canva blog, Meta blog, Zalando blog, Spotify, any of these resources. So I think we have also reached me out on LinkedIn. Find me at Victor Garcia Rubio. You can send me out an email at victorinfinops@gmail.com, or reply to any of the emails at FinOps Weekly. I read them all. So please, if you haven't subscribed to it, and you can reply to this and reach me out. And now let's dive to Q&A. Thank everyone. And let's see the questions that have been appearing on the chat. Let me open this again. Sorry about that. Okay. Let me see. Okay, thanks for going. Have you implemented Carpenter on AWS? Yeah, so I'm not working right now on AWS, but Carpenter is a tool that everyone is talking about when addressing AWS AKS workloads. So I would definitely suggest that. I have to make it. I have to make it work, because I haven't in AWS. But definitely, I would suggest that as well. I haven't mentioned because I haven't used it, but everyone is saying good things about it. What approach or tooling can you recommend to gain better insights into cost allocation of multi-app Kubernetes deployment? That's a really good question. I would say probably I would start with some tagging of the workloads. In your provider, you would be able to use the native tools such as the Cost Explorer or BigQuery for billing data in GCP or in Azure. The Azure Cost Management. And with tagging, you may be able to leverage those. If it's multi-app, you could probably use the metadata and querying that I'm not 100% sure about multi-app clusters because I tend to use one cluster per app, at least in my deployment, because we tend to make them like there are enough workloads there. But yeah, it's a good question. I hope with tagging and native tools you can do that. Okay, thanks. Yeah, thanks everyone for dropping here. It's been a pleasure to talk to you today. I don't know if anyone has any more question. I'm going to check on the question. Yeah, there is none there. So if anyone has any question, we have a couple of minutes left. If not, we can close. Let me see if I missed any because I may have. No. So Chris, thanks a lot for your question. Definitely. Yeah. So I don't see any more questions. So I think we can wrap it up. Thanks everyone for joining. It's been a okay. Do you recommend have any AWS native tools? Yeah, the AWS Cost Explorer or the Kudos dashboard. They are really good tool to see if you are working towards seeing your costs. Definitely those ones. Carpenter is an open source that I'm not totally sure whether or not it's maintained by the AWS people. How can the recording will be shared on LinkedIn and or YouTube on the Proficial apps. But yeah, so you'll be able to see there, and if you follow me on LinkedIn, definitely you will be able. Yeah. Yeah, it's available on for AWS. I think the AWS people collaborate with the Carpenter maintainers. I'm not totally 100% sure. I think it is, but because it has been shared on the AWS, so I would 99% say that they help to maintain. It's open source. So definitely a tool that is worth checking. Let's see if there are more questions. Okay. Thanks for the question, Walid and Chris. Thanks for the introduction. And yeah, it's been a pleasure, guys. I will stop sharing now. And yeah, see you in another occasion.